Hello everyone, this is Mrs. N. Arulsumati, Assistant Professor, CSE Department, Rogini College of Engineering and Technology. In this session, we are going to discuss about timing diagrams in 8085 microprocessor under the Unit 1, Introduction to Microprocessors and 8085 Architectures. Timing diagram. Timing diagram is a graphical representation. It represents the execution time taken by each instruction in a graphical format. The execution time is represented in T states. Control signals. IO slash M bar, which is active low signal, then S1, S2 status signals, data bus status, that is output. If both the signals IO slash M bar S1 S2 0 means it is in the state of halt. If the bits IO slash M bar 0 and the S2 bit is 1 means it is memory write operation. And 0 1 0 which means memory read operation, 1 0 1 which is IO write operation. If the IO slash M signal is 1, S1 signal is also 1, S2 is 0 means it is IO read operation, 0 1 1 means that is opcode fetch operation. If all the three signals are active, which means 1 1 means it is interrupt acknowledge. Instruction cycle. The time required to execute an instruction is called instruction cycle. Machine cycle. The time required to access the memory or input output devices is called machine cycle. T state. The machine cycle T state. The machine cycle and instruction cycle takes multiple clock periods. A portion of an operation carried out in one system clock period is called as T state. One T state contains rising edge or positive edge, which means it contains the falling edge or negative edge. Machine cycles of 8085 microprocessor. The 8085 microprocessor has 5 basic machine cycle. They are opcode fetch cycle. It contains 4 T states. Memory read cycle. It contains 3 states. Memory write cycle, IO read cycle, IO write cycle. Each cycles contains 3 T states. Machine cycles of 8085. The processor takes a definite time to execute the machine cycles. The time taken by the processor to execute a machine cycle is expressed in T states. One T state is equal to the time period of the internal clock signal of the processor. The T state starts at the falling edge of a clock. Opcode fetch machine cycle of 8085 microprocessor. The opcode fetch machine cycle contains totally 4 T states. They are T1, T2, T3 and T4. The first signal is clock frequency. Here the every T state it contains the rising edge and the falling edge. So here we have 4 rising edge and 4 falling edge also in the clock signals. Next one is A8 to A15, that is higher order bus. So first 3 states it contains the higher order memory address and the T4 state it is unspecified. And AD0 to AD7, so this is the address data bus. Here for T1 state it contains the lower order memory address, and then T2 and T3 state it contains the opcode. Then ALE, address latch enabled. So it is active high in T1 state, and remaining all the 3 state it was in this condition active low. IO slash M bar S1 S0. Here in this status signal IO slash M bar equal to 0 and S1 equal to 1 and S0 also 1. Then read bar. So here in this condition T1 state it is active high, and T2 and T3 state it was active low. Opcode fetch machine cycle of 8085. Each instruction of the processor has 1 byte opcode. The opcodes are stored in memory. So the processor executes the opcode fetch machine cycle to fetch the opcode from memory. Hence, every instruction starts with opcode fetch machine cycle. The time taken by the processor to execute the opcode fetch cycle is 4T. In this time, the first three T states are used for fetching the opcode from memory, and the remaining T states are used for internal operations by the processor. Memory read machine cycle of 8085. So this memory read machine cycle contains total 3 T states. So clock signal is also, it contains every T state, falling edge and the rising edge, and A8 to A15 that contains the higher order memory address, and AD0 to AD7 in the first T state it contains lower order memory address, and T2 and T3 states it contains the data in ALE address latch enabled. In T1 state, it was in the active high condition, and for T2 and T3 states, it was in active low. And IO slash M bar S1 S0 here. IO slash M bar equal to 0 and S1 equal to 1 and S0 equal to 0. At the same condition, read bar. So in T1 state, it was active high, and T2 and T3 state, it was active low. The memory read machine cycle is executed by the processor to read a data byte from memory. The processor takes 3 T states to execute this cycle. The instructions which have more than 1 byte word size will use the machine cycle after the opcode fetch machine cycle. Memory write machine cycle of 8085. So here this memory write also contains totally 3 T states, T1, T2, T3, and a clock signal also contain falling edge and rising edge, A8 to A15 that is higher order address, AD0 to AD7 which was in T1 state it contains lower order address, and T2 and T3 it contains the data address latch enabled. The signal was active high in T1 state and it was active low in T2 and T3 state. IO slash M bar S1 S0. Here IO slash M bar equal to 0, S1 equal to 0 and S0 equal to 1. Here write bar signal. Write bar signal is active high in T1 state and active low in T2 and T3 states. The memory write machine cycle is executed by the processor to write a data byte in memory location. The processor takes 3 T states to execute this machine cycle. IO read cycle of 8085. The IO read cycle is executed by the processor to read a data byte from IO port or from the peripheral. The processor takes 3 T states to execute this machine cycle. The in instruction uses this machine cycle during this execution. Here, this is the diagram of IO read cycle. So here we have three T states. They are T1, T2, T3, and the clock signal contains rising and falling edges. And A8 to A15 it contains the IO port address, and AD0 to AD7 which contains IO port address in T1 state, and it contains the data in T2 and T3 states. And ALE was enabled which was high in T1 state and which was low in T2 and T3 state. Then IO slash M bar S1 S0 here IO slash M bar equal to 1, S1 equal to 1 and S0 equal to 0. And the read bar signal is active high in T1 state and which was active low in T2 and T3 states. IO write cycle of 8085. The IO write machine cycle is executed by the processor to write a data byte in the IO port or to a peripheral, which is IO mapped in the system. The processor takes 3 T states to execute this machine cycle. Here, this is the diagram for IO write cycle of 8085, which contains totally 3 T states. Then the clock signal contains the rising edge and the falling edge, and A0, A8 to A15 which contains the port address, and AD0 to AD7 which contains port address in the T1 state and which contains the data in T1 and T2 and T3 states. And this ALE address latch which was active high in T1 state and which was active low in T2 and T3 state. And the write board signal is active in T1 and which was active low in T2 and T3 state. And the signal IO slash embar S1 comma S0, it is IO embar equal to 1 and S1 equal to 0 and S0 equal to 1. Thank you.